Okay, we'll see what happens. Hopefully it's recording my voice. So first thing we're looking at is polygons. And for something to be a polygon, the biggest thing is that it has to be closed. Everybody understand what I mean by closed? Hey, that's not a polygon. Okay, so it will be closed. Okay, every vertex, well, it won't always be labeled, but most of the time it'll probably be labeled. To name this polygon, this would be polygon, let's say DEABC. Hey, when you name it, it does not have to be in alphabetical order. Okay, it does not need to be specifically clockwise or counterclockwise. But it does matter that if I start at this point and go this way, that my points are in order. Okay, don't go D, E, B, C, A. Okay, that's not going to make any sense. Okay, it's going to tell you what point to go to next. Now also notice there's how many points on this polygon? There are 5. How many sides are there? Also 5. That number will always be the same.
At this time, if you have juniors, please come to the Performing Arts Center. Once again, juniors, at this time, please come to the auditorium. Thank you.
Okay. So, that part, excuse me, does not matter what letters go where. Okay. But notice, no matter how many letters you have, that's how many sides there are. Okay, so if I gave you a polygon and just named it without drawing it, and there was 7 letters in it, you would know that it had 7 sides. Okay, can we handle that? Okay. The next thing with your polygons are there's one way to classify them is whether they are convex or concave. I'll give you an example of each. This one is convex. This one is concave. What's the difference, Paul? Yep. Exactly. It's going to angle in instead of out, right? The way a lot of people in the past have liked to think about this is that has the word cave in it. Is this side caved in? Yeah. Hey, if you want to think about it as it has an angle, a different angle alignment, that's fine. However you want to remember it, I don't care. Hey, I'm just telling you what students have liked to use in the past. That seems to have worked. So if it caves in, it's concave. If it does not cave in, it must be convex. Okay. All right, taking a look here on the left side of your page, on page 30, it gives you a list of different types of polygons. A lot of these you should know. You should know that a triangle has 3 sides. You should know if it has 4 sides, it's a quadrilateral. 5 sides, it is a pentagon. 6 is a hexagon. 7 is not one that's commonly known. 7 is a heptagon. 8, you should know because the stop sign is an octagon. 9 is nonagon. 10 is decagon. 12 is dodecagon. Okay, those you can all find. They're pretty easy. Now, notice we skipped 11, and after 12 it says that they're just n-gons. Okay, n is the number of sides. So if something has 27 sides, we call it a 27-gon. Okay, just that way we can easily name any shape with any number of sides up to whatever. Okay, does that make sense? If it has 11 sides, you're going to call it a what? 11 sides? 11 gone. What you guys need? Oh, you guys have freshman lunch? It probably won't work during freshman lunch because I got class, so I got to teach. Before school tomorrow? That work? Okay, thanks guys. All right. So, taking a look here at example 1 just quickly. Part A. Casey, is that part A convex or concave? That is concave. And Dylan, how would you classify that based on number of sides? Example 1, part A. 4 sides, so it is a look at your chart. Quadrilateral. Emma, part B, convex, concave. Convex, good. And Jersey, it is a hexagon, good. Okay, so moving on, we're close to example 2. We're going to start doing the perimeter and area things. Okay, with your perimeter, they list you a whole bunch of equations. How do you find perimeter? Add up all the sides. Okay, if you don't want to go off their equations, that's fine. Okay, just understand they're there. And you should at this point know how to find the area of a triangle and a rectangle. A square, if you want to think of those extra equations for a square, you can and use them. But is a square a rectangle? Yes, it is actually. Okay, a square is a rectangle. So, could you just use the rectangle information on a square and save yourself 2 extra equations? Yes. Okay, so however you want to do that, I don't care. You guys have done a lot of this. I don't expect you to struggle with the idea of how to find perimeter and area very much. Okay, so the first example, finding perimeter and area. They ask me to find the perimeter of triangle PQR. So we're finding perimeter of triangle PQR. Point P is at -1, 4. Point Q is at 2, 4. And point R is at 2, -1. And they're asking us to find the perimeter of this. Now, did anywhere in those directions, did it ever say graph the triangle? No. So, am I going to require you to graph the triangle? No. But if you didn't graph the triangle, you would have missed something that would have made this problem much easier. Okay? What do you know about PQ? It's 3 units, right? You can count that because it's perfectly horizontal on a coordinate plane, right? Would you have known that that was a perfectly horizontal segment without graphing this? Probably not. Okay, some people can look at it visually and see it, but most of us probably wouldn't have caught that. QR is how long? 5 units. Same thing, you probably wouldn't have caught that it was perfectly vertical. Oh, camera fell over. You probably wouldn't have caught that was perfectly vertical if we were not on a coordinate plane. Okay? So, if you graph it, you're probably going to save yourself some time. Okay? Because what's the only other way to find the length between 2 points that we've learned? Distance formula. Okay? It would have kind of stunk to do distance formula 3 times and then graph it and found out that everything was a solid length and that you could have just counted. Okay, so graph it. Don't waste your time doing distance formula when you don't have to. Am I going to have to for PR though, since it's at an angle? Yeah. Hey, we don't have a choice here. So it's 2, -1, and -1, 4. So when I plug this in the distance for PR, what comes first? 2 or -1, it really doesn't matter, right? But if I do 2, then it's minus -1, which is actually +1 squared, plus -1 minus 4 squared. Good. And so now be careful here. I watched 3 people so far today. They did this first part, but then they got lazy and they started going down and they just stopped drawing the square root. And then they got to the end and they're like, well, I plugged in 89, but it said the answer was wrong. Well, yeah, because it was actually the square root of 89. You were just too lazy to write it 2 more times. Hey, don't be lazy. Go ahead and write it. I promise you going like this is not going to take enough time out of your day to bother you. Okay, so make sure we bring that down with us. 2 plus 1 is squared. -1 minus 4. Is it 3 or -5? -5. I'm -1 and I'm taking away 4. So I'm -5 squared, 25. So I have the square root of 34. Okay, now on your homework, they're going to ask you to round the answer to the nearest hundredth. Okay, so I'll go ahead and give you this one. This is 5.83. Okay, so what did we just find? We found how long PR is. Good. So 5.83. Okay, and we're trying to find in the end, our goal is to find the perimeter. So the perimeter of this triangle is 13.83. Good. Do I need a label? Units. Good. Again, that's what I don't like about big ideas is they always label for you. Okay, I wish you had to do that, but make sure on Fridays when we take our homework quiz that you get a label on there. Okay. Correct me if I'm wrong, but the hardest part about that was taking our time to do distance formula. Everybody knows how to find perimeter. Okay, that's not hard. Everybody can count segment lengths when they're horizontal and vertical. It's just taking the time to find the distance of a diagonal or of an angled segment. Okay, so moving on, flipping over, the next one we are going to find area. On this problem, they ask us to find the area of triangle ABC with vertices at 1, 3, 3, -3, and -2, -3. Now again, we're finding area. So, when you're finding area, do you need to know all the side lengths? No, you need to know what? You need to know your base and you need to know your height. Okay, which segment would be our base? CB or BC, same thing, right? There's our base, which has a length of 5 units. Is the height one of our segment lengths? Losing my camera again. Got to get this thing fixed. Is the height one of the segments our height? Why not? Because they're at an angle. What do you know about a height? It's always straight up and down, right? And when you measure your height, you're not leaning over when you measure it, right? You're standing straight up. Okay? So your height's got to be perfectly vertical. So neither of those segments, AB or AC, neither of them is going to be our actual height, correct? So would it be a waste of our time to do distance formula and find the lengths? Yes. So understand what they're asking. Now, if they wanted perimeter, would you have to go do that? Yeah. But they don't want perimeter. They want height. So your height is going to go from A, where? Straight down to somewhere between C and B. So there's our height, right? Which is 6 units. I'm struggling with that camera. See if this works. That should help. Okay. So that's 6 units. Can I now find my area? Yes. Area is equal to 1/2 base times height. Base is 5, height is 6. My answer is 15 units squared. Good. We are in area, so we are talking square units. Okay. Again, not too bad. Okay. What you do have to be careful of is sometimes you're going to have to find your height and it's not going to be part of your triangle. Up here, was your height part of your triangle? Yeah, 3 would be your base, 5 would have been your height. Okay, there it's part of it. Down here, it's not. A question I had during first period, I think it was, okay, if I have to find my height, will it always be inside my triangle? No, it won't be. If your triangle is obtuse, your height is actually out here. Okay, your base would still be here, but your height's clear out here. Your height is always going to be from the highest point to the lowest point. Okay, for what we're working with. Now we'll talk about some things that are a little bit different. It'd be different if everything was angled. Okay, we'd have some different things to do. Okay, but for now, for what we're doing, you're going to have at least one horizontal or vertical segment every single time. Okay? If you needed to, let's say I have this. That makes it a little harder because what you guys would typically think of as the base is at an angle, right? Is it okay to call this the base and say this is the height? Yeah, you just got to imagine it turned sideways, right? Okay, so alter that because this can be the base and you can easily count that. Okay, so you might have to use your imagination a little bit, okay, but you should be able to work through those. One more problem here. This one's a quick one, pretty easy. Hopefully as I start drawing it, you think it's easy as well. They're making a banner for a basketball game, and the first point, the vertices of it are at 1, 1, 7, 1, 7, negative 2, and 1, negative 2. Just had to think there, make sure I've got those in the right place. Okay, A, B, C, D. They want to know what's the area of the banner. Okay. They also go on to tell us that each unit in the coordinate plane represents 1 foot. What do I need to know to find the area? Okay, base and height, length and width, however you want to think about it, I really don't care. So the base or the length would be 6, height is 3. So the area is, careful I gave you a little extra information. What did I say about each unit? Each unit is 1 foot, so it's 18 feet squared. Okay, as I was drawing that, hopefully you were seeing rectangle and thinking this is going to be pretty easy. Okay, rectangle should be easy for you. Okay, they don't ask for perimeter, but could I find it pretty easy? Yeah, because if this is a rectangle, if this is 6, this is 6. If that's 3, this is 3. So my perimeter would be 18 feet squared. Why? Yeah, it's not area. Only area is units squared. Okay. Will your perimeter and area always be exactly the same? No. Actually, very rarely will they be the same. Okay, so don't expect that. That's a very rare case. Okay. Any questions on that? Like I said, I think the idea of what we're doing is pretty easy, right? Okay, just don't forget your distance formula. You might have to use that. They're going to challenge you on some of their homework questions. So be ready for that. Okay? Any questions before we get started? Okay, you have the rest of the class to work on your assignment. And I'm going to see if I can figure out my camera.